assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, we are given two equation here with their um, equilibrium constant, and we have to find out the equilibrium constant for this equation here. So to solve this problem, let's first reverse the first equation, or equation 1. By writing it reversely, we can write it HbO2 Hb plus O2, and the equilibrium constant here, if we just let it K prime as 1 over 2 times 10 to the power 12, it will give us a value of 5.0 times 10 to the power minus 13. So now let's see how this equilibrium constant was found. So if we like it in the equation form, K prime here is equal to HbO2 over this one, HbO2. And then for the second equation, we have our equilibrium as HbCO over Hb and CO. And for the equation, we need to find the equilibrium constant. Here our K is HbCO times O2 from these two, and put it over these two. Here HbO2 times CO. So now if we multiply these two here, that means K prime and K, from these two we will have Hb and O2 over HbO2 times this one, that means HbCO over Hb and CO. So now we have we can just cross Hb from here, and then we have the net equation as HbCO and O2 over HbO2 and CO. So if you see that this is identical to this one, right? We have HbCO here, we have HbCO here, we have O2 here, we have O2 here, we have HbO2, HbO2, CO, CO. That means if we just multiply this value with the equilibrium constant of the second equation, we will get the equilibrium constant for this equation. So the value here is let's go to this one. So the equilibrium constant for the equation given is equal to K prime times K2. If we just consider that 2, that is actually so this is 5.0 0.0 times 10 to the power minus 13, and another one we have 1 times 10 to the power 14. So in total, if we just calculate it, we can see that the value is 50. So that means the equilibrium constant for the given equation is 50, and we know that if a equilibrium constant value is greater than 1, then it will favor product over reactant, and that means this equilibrium we are given here will favor product over the reactant.